Today we're looking over a pattern of design techniques called the Observer. Uh, my name is Thomas Nielsen, and I'm here with Mila Romero. We are going to look into how this is defined, how it is used, the pros and cons, as well as the risks and what we would use it for. So the very first thing is, what is an observer um, technique? The observer is basically two things. You have a subject or an object, which is one thing. It's one entity, and then you have the the observer or the dependence. Um, there are usually many objects that observers can see or interact with when there's only one subject or class that is being worked upon. The system can be asynchronous or synchronous with how it is being detected. With, it can have it working through a time period, or it can just wait till a listener is triggered or a button is pressed. One of the big important things with an observer is that it's hardwired into the code that you're presenting. Uh, uh, One other thing with the hardwire is the subject, however, does not have to be hardwired into it. The subject can be remotely accessed through, another call from another system or another class or even another function. It doesn't have to necessarily be in the same um, hardwired system or interface. This observer technique is also known as event-driven software, where we've done it in many types of software like Java or other types of object-oriented designing techniques. So this is where we demonstrate the how we would use an observer. Observers, as I said, you can set them almost anywhere inside of a program. The program here I basically made a mock-up UML of it. And there's a lot of things that are missing from it. However, the basis of it, I'm only going off of seeing whether or not a store would be available to order items from. So when you have your user, the user looks at it, makes a shopping list. That shopping list has to get the state of the stores that are available. So you look that I randomly chose three, stores. You have Trader Joe's, Costco, and Winco. Each of them have their independent hours, and that observer would make them available or not available by just saying, "Hey, are you currently open?" An observer can do way more than that. It can go into, looking at items, see if the items are available. It can go into, say that you want to observe or see if the user changed their password, or if they removed an item. So observers really can be used in many locations. A lot of programs use this, like Java, like I said, with the object-oriented design. There's a lot of users uh, of listeners and observers, and so that's where I was going off of with my experience. So now Camilla will tell us about some of the benefits and risks.
Thank you, Thomas. Yeah, so let's start with the benefits. In the first place, Observer Pattern is a great contribution to the support of open closed design principle. The open closed principle is warranted because new observers or subscribers can be added without breaking the observable's existing code and vice versa. Another benefit is that the code is more maintainable because there is less coupling between the observed object and the observer objects. The observed object does not require any type of information about the observers, since the interaction is carried out independently through the observer's interface, which receive updates automatically. However, automatic updates by the subject to all registered observers are not always beneficial because the transmitted change information may be irrelevant to some observers. This process is inconvenient, especially when the number of registered observers is large, because it wastes a lot of computing time. Another risk of the observer pattern is that the subject's source code does not always reveal which observers are reporter. And also, the information can lead to memory leaks within the program. Thomas, would you like to explain us more why the information can lead to memory leaks within the program?
So if you have a program that is trying to be quote unquote automatic, this uses memory on the computer or on the system. Within each observer that you have leads to a possible additional use of resources. If you have unlimited resources, you don't care about memory leaks. But most people, if you're running a program, if it's running Java, if you've dealt with Java in the past, if you run a really large program, the computing power to parse through everything that you have to go through to check to say, hey, are you awake? Hey, are you awake? This can lead to some major downtime. It's not the most speedy of programs. It's not, it has to, parse through sometimes thousands or hundreds of thousands of lines of code. And that it can be not very efficient.
Thank you, Thomas. So now we're gonna talk about when is a good option to use this technique. So you want to use observer pattern when changes in the state of one object may need to change other objects, and the group of objects is known in advance or changes dynamically. For example, we can have a user interface with different views of a value, and we want these views to be modified automatically whenever this value does, or launch events when a certain change occurs in a file or a certain mail is received. When is it effective, this technique? Well, the observer pattern can be effective when updating multiple objects, performing a system action, or interacting with a user. As we mentioned before, the observer pattern can be effective if you apply it in any situation where you have multiple objects that depend on another object and are required to perform an action when that object's state changes, or when one object needs to notify others without knowing who they are or how many there are.
So this is our work citation for this presentation. These are the several questions that we have for the coming quiz. Thank you so much.
Thank you.